Hello, Algebra 2. Chapter 7.3 has so much information in it that it really deserves two lessons. And in fact, that's what I'm going to do with the videos. I'm going to make two separate videos coming out of Chapter 7.3. And it's not based on the title. Even though there are two concepts here, I'm actually going to cover both of these in this first video lesson. In fact, most of what I'm going to talk about is the second concept here, function operations. I'll just touch on power functions at the very end of this video lesson. So as I say, I'm going to start with function operations. Let's start with a situation where you would actually do what function operations talks about, where you would actually put two functions. You might think of them as two formulas together. First of all, one formula for cost. A company has figured out that the way it can calculate its costs is based on this formula right here, 0.75x. In other words, it might be 75 cents. 75 cents times every product that it sells. Let's say that the company sells hair dryers. Well, it costs it 75 cents for every hair dryer plus $20,000 that it spent maybe to create the company or build the factory. It also has a separate formula, a separate function for revenues. And revenues can be modeled by this formula here, 1.50 times x. So maybe it's that it makes $1.50 for every one of these hair dryers. It's a very cheap hair dryer. Maybe I should have come up with a different product, but you get the basic idea. The price is $1.50. Every time it sells its product, it makes that much money, but it also costs it 75 cents for every one of those products, plus the $20,000 to build the factory. Okay. To figure out the profit for the company, you have to put those two ideas together. The profit is equal to the revenue minus the cost. So put these two functions together. If you're going to determine the profit, particularly when 1,000 units are produced, what you need to do is put together, like I said, the cost and the revenue in this formula. Well, the formula says profit is equal to revenue. Well, we said revenue is 1.5x. minus the cost, and we said the cost is this piece here. Well, that's what you do, is you calculate that out. Put in 1 million units, 1 million in for x here, also in for x there, and you can figure out what the profit is. I'm not going to walk you through that. Instead, I'm going to pull out this green box from chapter 7.3 and point out that you can not only add or subtract functions, you can also multiply and divide them. And we're going to talk about examples of each of those in this video. First of all, adding and subtracting. Well, let's say shorter functions than the ones for that company. The first function, we'll call that one f, is equal to 2x to the 1/2 power. And the second function, we'll call that g, is equal to -6 times x to the 1/2 power. Okay, well, if you have to add those two things, all you do is plug them in. And you've got two of these things called x to the 1/2 and also -6 times x to the 1/2. Combining those, 2 and -6, you've got -4 times x to the 1/2. If you've got to subtract them, again, plug them in. And minus minus is going to become plus, so you're going to end up with 8 of those things called x to the 1/2 power. That's adding and subtracting. There is one important concept in composition of functions that we haven't talked about a whole lot this year, only a couple of times, but it becomes crucial here. Domain. Domain basically talks about the x values that are or are not allowed to be used. In this case, you can use any number that's not negative. Why can't you use a negative number? Well, remember, the 1/2 power is the square root. And you can't take square roots of negatives. Those are imaginary numbers. If you were trying to figure out the profit or loss or cost or revenue for a company, if it had a square root in the formula, you can't have an imaginary answer for that. So the domain is going to say you can use any number you want for x as long as it's not negative. If you use a negative, you're going to end up with imaginary answers. Okay, so I'm not going to ask you to figure out the domain for now. Just go ahead and do the work, both for, as it says, add them and also subtract them. Do number 2, put this function together with that one, and also do number 3. I'm just going to show you the answers for both of these. when you have finished adding f and g for number 2 as well as f and g for number 3 and subtracting f and g for number 2 and for number 3, then come back and I'll show you those answers. But for now, hit the pause button. Okay, I'm going to assume that you've done that, and here are those answers for number 2 and number 3. The left answer here is when you added them. The right answer here is when you subtracted. Same thing for number 3. This is what you got when you added them, and this is what you should have gotten when you subtracted them. Of course, you can hit the pause button and study these answers. If you didn't get those answers, come into class and we'll talk about that. I'd be happy to answer any questions. But in terms of this video, I'm going to move on to multiplying and dividing. Again, 2 sample functions, 2 sample formulas. F is the function 3x, and g is the function x to the 1/4 power. If you have to multiply those two things, plug them in again. 3x times x to the 1/4. Well, remember the rules that we learned. X to the 1 times x to the 1/4, you simply add those exponents. 1 plus 1/4 is 5/4. Do remember that all along throughout this, the exponent only applied to the x. It never applied to that 3 out in front. So you should not have any parentheses in your answer. B, this time we're dividing them. Putting 3x in the top and x to the 1/4 on the bottom. Well, again, remember that's x to the 1. So you've got 1 minus 1/4. And 1 minus 1/4 is 3/4, but that 3/4 only applies to the x. So you end up with 3x to the 3/4. Again, let's talk about domain. Well, for f times g, you can use any x value as long as it's not negative. Non-negative real numbers, you might remember going back to the very beginning of the year, start with 0 and go up. Any number that's not negative is okay. Why can't it be negative? Well, again, this is an even root. It's not the square root, but you can't take even roots of any amount, whether it's the second root or the 4th root or the 18th root. You can't take them of a negative number. So can't use that for f times g. For the dividing, you not only can't use negative numbers, you can't use 0 either. That's why they say it has to be positive, and that's the difference between non-negative and positive. We talked very briefly about this way back in September, but the distinction here is that positive numbers do not include 0. Non-negative does include 0. Why can't it be 0? Because you're dividing by a value that has x in it. If x were 0, you'd be dividing by 0. You get an undefined answer. So you can't use 0 as one of your possible values of x. Okay, again, I'm not going to ask you to worry about domain and range for now. We'll worry about them in class. But do go ahead for 6 and for 7. This time just figure out what they multiply out to be. Don't worry about dividing. So for 6, put f times g. And then for 7, again, f times g. When you come back, I'll show you the answers for those two things. Okay, I'm going to assume that you did that. Here are those answers for 6. This whole string of terms here, this long polynomial, is the answer for 6. A much shorter one for 7. Hit the pause if you need to study the answer. Come into class if you have any questions about that. Now for dividing. Let's see. I want you to do 11 and 12. It's going to be f on the top and g on the bottom. And also for 12, f on the top and g on the bottom. Hit the pause button. When you come back, I'm going to show you the answers for 11 and 12. Okay, I'm going to assume that you did that, and there's 11. And there's the answer for 12. Again, I'm happy to explain these. If you have any questions about them, bring those in and we'll talk them over. I promised that I would also talk about power functions and not just function operations. As I said at the very beginning, I'm only going to touch on this concept. But a power function has this form. Y is equal to ax to the b power. A can be any real number. B has to be a rational number. So in other words, it can't be pi. Can't be irrational. But as long as that's true, as long as you've got a coefficient, of course the coefficient could be 1, it could be negative 1/3, and as long as b is not pi but any rational number, you've got a power function. Notice that when b is positive, for example, x to the, and more specifically, a positive integer, such as x to the 3rd power, then you've simply got a polynomial. That's what we've been talking about for the past couple of months, is polynomials. So power functions are a superset, and inside that superset you'll find polynomials. So for example, if, oops, didn't mean to move that. If b is 1, then you've simply got a linear function, what you studied back in Algebra 1. If b is 2, you've got a quadratic, which is what we began studying in December. If b is 3, you've got a cubic function, and so on. That's what power functions are. We'll start talking about how to make use of that information later. But for now, that's it for this video lesson. Bring any questions that you have to class. And as I say, there is going to be a separate video lesson about another concept out of this chapter.